Okay, this is Andrew McNamer with assignment 1. As you can see, all 6 tests pass, and the memory tracking passes as well. So I'm just going to go over the snake class because it was the most difficult one. So we start with the egg object that we have to serialize, or the egg object, which is a part of the snake object that we have to serialize. Then the double linked list node that we also use, and then the overall list object of Medusa. Okay, so for deserializing the snake, we follow the serialize. We can go over that first. Write object to a buffer. We assert that the length is at least the size of the class. Add a p buffer, which is our cursor that we can move through the buffer with. And then we start with the key. So I mem copy into the buffer the key of this associated snake node. And then we go through the egg object, and we get the A, X, and B. And then we are moving the buffer every time, or the cursor every time after we mem copy, so that we're copying into new unused portions of memory. And then on the deserialize, it's the same thing. We just make sure the length is at least the size of the class. Put a cursor, create a new egg object, because when we use the snake object, the default constructor leaves this as a null pointer. So you have to create a new object. And then mem copy the key into the snake object from the buffer, because it was the first thing we put into the memory buffer. And then we go through in the same exact order, A, X, and B, and put that into the new egg object. Okay, and then when we get to the actual list object for serialize, we, again, just make sure the size of the class is at least as long as the buffer. We get in. Basically, we're setting the cursor node instead of a buffer cursor to the head of the list that we're going to use it to move through. And then there's our buffer cursor as well. And then we're checking while we have nodes in the list. We get the snake from the snake link casting. We serialize it using the function up here for each individual node. And then we simply move snake link to the next node, and then move the buffer plus the size of the key, the egg.a, x, and b size of the actual things, because this will move us as many bytes in the buffer that does not include the padding. And then at the very end, we do pbuffer and set this as a sentinel value, which we will use when we deserialize to know that we're done. So on deserialize, same stuff up here. We set a constant p-char. I could also just do a regular character. I just chose to keep it a pointer. To the sentinel value, set a previous to null pointer. And we're going to use this in the list creation. And then while pbuffer does not equal this sentinel value, we're going to move through, create a new snake, use that to deserialize into the movable buffer and length. And then because insert snake inserts at the very front of the list, if the head is null, which means there's no nodes in the list, we're going to insert it at the front. Otherwise, we're going to go through and just tag it onto the previous node. And then when it goes through this, we set previous to the current, because we will be creating a new one every time. And then move the buffer the size of key in the egg object. And that is assignment 1.